Okay, so this is going to be a midterm revision on ASCS 2284 operating system. So just a disclaimer here, please read through this one where this recorded session, right? It's just to revise with you, okay? There's no any, it doesn't imply of any midterm examinations or any special guidance over here. So you should not share or distribute this without proper authorization. Okay, now look into the key content, yeah? So I'm going to talk about the scheduling algorithm here. Okay, so out of here we got 5, where priority scheduling is actually have preemptive and non-preemptive. But no worries, I'll go through one by one later. Now you have to know how to calculate your average waiting time and turnaround time as well. So I will go through one example in this video. And if you have any questions or problem later on, you reach out to me. Okay, and later I'll talk about this resource allocation graph or directed resources allocation graph lah. It can have some different meaning, not meaning but different term where the questions came out, but you just have to know that they are the same thing. And finally, we'll talk about the Banger's algorithm, whether to determine that is it a safe or unsafe state. So in the meanwhile, I will refer to your to some of the lecture notes as well. So if you have any issue, just reach out to me. Okay, now let's quickly go into the first one. So I actually screenshotted a sample question over here. So we're going to do it together. I mean, I'll do it. Whenever you watch this, you have questions, just come to me. Okay. So now a few things to highlight before we start. So no matter which algorithm, is it preemptive or non-preemptive? Okay. First thing first, we always look at the arrival time. So please make sure you look at the arrival time. Okay. Then only go through the condition. Sorry, wrong text. Okay. Now wait one moment. Only go through the over here we go through the condition second. Okay, so what does it mean by arrival time? We refer to this thing, arrival time. So at 0 milliseconds, this is milliseconds, right? So 0 milliseconds, the process A have reached. Okay, so this is arrival time. Now the condition, okay, second thing I talk about condition is referring to the algorithm here, the scheduling algorithm. If we say first come first serve, right, which means who come first, we let the CPU do that process first. That's the condition. So you see, at 0 millisecond, A come first. At third millisecond, then only B came, right? So in this case, if we're using the first come first serve, you see who come first. Oh, now arrival time A is 0. So definitely we are going to process A first, followed by B, C, D, and E. Just go like that. Okay, but there's different condition, right? Let's say for priority, we look at who have a greater value implies a higher priority, this and that. Okay, your question will give you that assume something implies a higher priority. So you have to look at it if larger priority number, which means if let's say 1, 2, 3, 4, 5, right? So higher priority is a larger number. So definitely 5, priority of 5 is going to be the highest priority. Now, if the question say a lower number, okay, a lower priority number implies a higher, then it would be 1. Okay, just that simple. So look at the arrival time. The reason of me mentioning arrival time is because some of the students, okay, when they are doing maybe like shortest job, okay, or shortest remaining time, they will directly look at the CPU cycle that have shortest value, like let's say 2. But you have to see this process B having a CPU cycle of 2, which is short enough, but they arrive at the millisecond of 3, which means the first job that you draw in the Gantt chart shouldn't be B. Okay, so that's the case where you have to look into the arrival time and condition. So in the meanwhile, let me revise with you again on preemptive and non-preemptive as well. So you see here, first come, first serve, shortest job next, right? And also the non-preemptive priority, they are all non-preemptive. So what is non-preemptive over here and what is preemptive over here? Okay, for my students, remember, if really come out to ask you to differentiate, don't tell about cut queue. Okay, I know I mentioned a lot cut queue just for you to understand, but don't write cut queue. You say either there is interrupt. So the keyword here is interrupt. You either say yes, allow interrupt, or there is no interrupt. Okay, for further information, refer back to your slides. Okay, so now non-preemptive and preemptive. For preemptive, you will have interrupt, which means let's say the A, right, process A is 3 milliseconds. But maybe after 2 seconds being processed, right, your CPU have to let another process to use it. So there is an interrupt occurs. We'll actually switch or you swap the job. So that is called interrupt, which is preemptive scheduling. Now, if non-preemptive, which means the moment you start the process, right, you cannot say halfway you want to let another process for your CPU to run. You have to wait until the first or the current process that is processing to end, then only we can go to the next one. Okay, just that simple for preemptive and non-preemptive. Now, if we look into this one, okay, the easiest one, first come first serve algorithm. Now, at first, you have to draw a Gantt chart. So you start with 0 lah. Okay, and you see now, A come first, right? So imagine you're going to process your A. And for the CPU cycle of 6 milliseconds, so you're going to take up 6 seconds for you to finish it lah. So imagine at 6 milliseconds, right, you have B process and C process arrive already, right? So who should you process next? Is it B or C? Definitely we go for B because this is a first come first serve algorithm. Who come first? Oh, B come first, then only C. So no matter what, in the queue I have 2 jobs, but I'm definitely going to process B. Now, B have a CPU cycle of 2, so we're going to let it process for 2 seconds, okay, until 8. Now, at 8 milliseconds over here, we have a process C, right? So C is going to continue over here. You got a C, okay? And C is going to take up to 4 milliseconds. So 8 plus 4, you got 12, okay? Now at 12 milliseconds, all the job came already. D and E is also here queuing. Now we process D lah, okay? Because D come first. So D over here for 2 milliseconds, we got 14. And finally E, okay, we got a 4 milliseconds of 18. Okay, so just that simple. Because this recording session, I make it quite urgent. So if you realize any issue, please let me know at the end of the day as well, so I can make a clarification. So you guys are going to draw your line lah. I am not really, I couldn't draw well here. So you guys draw a line on your own, okay? Remember to draw one line here and one line bottom here. Now, with that being done, right? So this is a Gantt chart. This is just a Gantt chart, okay? So question says about draw a Gantt chart, must have Gantt chart, okay? Now, after you draw a Gantt chart already, remember to read your question, calculate the average. Now, average turnaround time and average waiting time based on each of the following algorithms, okay? Now, over here. So, turnaround time and waiting time, this one you have to remember. So, if you want to calculate the turnaround time, right, we just take the finish time minus arrival time. So you have to look into how you get the finish time. Now, arrival time is already specified here. Pretty simple. You just look at arrival time 0, 3, 6, 9, 12 for process A, B, C, D, E. Now, finish time, okay? Wait, let me check. Stay in the call. Okay, for the, where am I just now? Okay, now talk about it again. Arrival time is there already. For finish time, how you going to read it, right? For the, where's my mouse? Okay, for the finish time, you're going to take from your Gantt chart, which means make sure when you try to draw your Gantt chart, right, you don't make those careless mistakes. Because if your Gantt chart is wrong, definitely your turnaround time and average time going to be wrong, right? Waiting time, okay? So that's one thing you have to look into. And without further ado, let's just directly go and calculate now. I do the turnaround time first, okay? Every time I do this calculation, I will base on the process. So let's say I have A, B, C, D, E, right? And I want to calculate the average. Okay, let me change another color and write this here. Oops. Oh no, cancel. Just do the green color. Okay. Now, if to calculate the average, where's my pen again? Ayo. Okay, over here. Now, if I want to, okay, average turnaround time. Okay, I will follow the process by process because I want to get the average right. So I will start with the process A first. So let's see the finish time of A. Okay, you can refer here, which is 6. Okay, so you're going to take 6 and then you're going to deduct with turnaround time. You have to deduct your arrival time, right? So finish, deduct your arrival. The arrival of A is 0, so we put 0 over here. Okay, and we're going to add the process B1. Now the process B end at 8 milliseconds and it arrived, okay? It actually arrived at third milliseconds, okay? And process B is done. Now we go to process C. Process C end at 12 milliseconds and it actually arrived at 6 milliseconds, okay? And we're going to follow by the process D. The process D ends or finish at 14 milliseconds and it actually arrive. I don't know why I keep on saying start. It arrived at 9 milliseconds, okay? And one more, which is the process E, and at 18 milliseconds and arrive at 12 milliseconds. Okay, now you want to calculate the average, you add on all of them first. Okay, all of the turnaround time, you add them up together, sum of it, and divide by how many process are. So over here A B C D E 5 process, so I divided by 5. 我不要靠有人啊 ，5 process 跟我写4下去啊，写3下去啊 ，OK。If there's 3 process, you write 3. If there's 4, write 4, 5, and 6. You just write respective one, okay? One moment, let me check is there any issue here. Now, okay, with that being said, right, you tekan your calculator and then you will get your average turnaround time. Okay, so over here, what happened to my writing board? Something is not right here. Okay, anyway, so you go and press your calculator and then you get your value here. Okay, then you write it. Okay, so this is for average turnaround time. If the question wanted to calculate average waiting time, okay, if you remember turnaround time, right, they are just finish minus arrival. Same, finish minus arrival. But because we want to calculate the waiting time, we need to minus the CPU cycle. Now, where do you get your value of CPU cycle? Okay, CPU cycle just over here. Sometimes the question might not write CPU cycle. It gives you some other terms, but you have to know that it's actually your CPU cycle. Okay, so with that being said, let me just write the average waiting time over down here. So for your average waiting time, in order to calculate, okay, it's just a little bit similar with turnaround. It's just one more thing we have to minus, which is the CPU cycle. Now, start from process A again. Process A end at 6 milliseconds. Arrive at 0 milliseconds. This time we have to minus the CPU cycle, which is 6 milliseconds. Okay. Now the next one, process B, it actually finished at 8 milliseconds. Arrive at 3rd millisecond, and the CPU cycle is 2. Okay, followed by the next one, which is the process C, ends at 12 milliseconds, arrive at 6 milliseconds, and CPU cycle of 4 milliseconds. Okay, process D, 14, okay, minus 9, minus 2. And the last one, which is process E, and at 18 milliseconds, okay, arrive at 12 milliseconds and CPU cycle of 4 milliseconds. Okay, with that being written, this is just the sum of all waiting time. You want to get an average. Okay, I'm sorry, my line is a bit chat here. You have to divide by 5. Okay, because there's 5 tasks, process A, B, C, D, and E. Okay, same. Go and calculate. And that's going to be your answer. So remember, mention unit as well. I don't know whether you didn't mention with deduct amount or not, but since the question already give you over here ms, right, milliseconds, so you just follow back write the milliseconds down here. Okay, so this is for the first one, first come first serve, the easiest one. You don't ask me, teacher, this one will come in exam or not. I don't know. It might not. All right, now let us just proceed with the next one, which is shortest job next. Okay, and draw the Gantt chart first. Okay, so we're gonna start at 0. Non-preemptive, cannot, we say like cannot allow interrupt no interrupt. Okay, I don't care is it the upcoming job is the shortest one, as long as I already start the current one, even though the next job that coming in is the shortest, you have to wait. Okay, shortest remaining time will be contrast that actually allows interrupt. But anyway, just start here. Okay, to draw a Gantt chart, always start with a line and follow by this 0. Okay, so at milliseconds of 0, right, you got to process A. So your CPU won't wait one. It just, oh, there's a job, then I proceed with A first. Okay, and A takes up a CPU cycle of 6. So you just imagine, you don't write this in your exam, students. Don't write this in your exam. I'm just trying to picture it out. Okay, now A is start to process for 1 second, millisecond, 2 millisecond, and at 3 millisecond, process A is not done, right, because we need 6 milliseconds. But you look at here, at 3 milliseconds, okay, here, there is actually process B coming in. Okay, so process B is here already. Now, if this is a preemptive and you look at process B, that's actually just 2 milliseconds, you might need to handle the interrupt. But this is not a preemptive. So no matter at 3 milliseconds, there is a job coming in, even though it is shorter than process A, I continue to just run. Sorry, 为什么我跳去your CPU will just continue to run at this process A until 6 milliseconds, where this where this is being done. Finish execute. Okay. Now imagine at 6 milliseconds, right? You'll have another new arrival of job, which is C, right? Process C. So your C is under here. Now you have two process in the queue. You have to determine which to execute next. So if this is the shortest job next, the condition is the process that is shorter, I will execute it first. So you see B and C. One is 2 milliseconds, one is 4 milliseconds. So definitely we are going for process B lah, because B 2 milliseconds, which is the shortest, right? So your CPU say, all right, now let me execute on process B and take 2 seconds, right? So you imagine 4, 7, and 8. 2 milliseconds, right? 1, 2. Done. Okay, now process A and process B is already done, so my queue don't have B anymore. Now I left C, and you look at here at 8 milliseconds, there's no new incoming task, right? So no worries, I'll just progress with C that take 4 milliseconds. So imagine again, process for 1 millisecond, 9. There's a new process coming, which is a process donkey. Okay, but this is a non-preemptive, even though 2 is much shorter than the process C that you have executed for 1 millisecond, left 3 milliseconds. You are just continue with the C. Okay, so 1 millisecond, 2 millisecond, 3 millisecond, 4 millisecond, which is 12, and cut it off. Okay, because 4 millisecond, we're done with our C. So at this timing, right, your C is already done, no more C. But you look at here, at 9 millisecond, D is entered. D has entered, okay? So 9 millisecond here, D has entered, and 12 millisecond here, your E have also entered. Okay, so now you have two process in the queue, and you have to determine which one to be executed next, right? So you look at here, which one have a shorter CPU cycle? Okay, 2 versus 4, definitely you go for 2, right? So if I say go for 2, which means I'm going to process a D lah, okay? The D for 2 seconds, and you add at 14, and the E for 4 seconds, you're going to end at 18. Okay, how to check whether your Gantt chart is correct or wrong? Okay, there's one way you can check here. You just have to sum your CPU cycle, okay? At the last part here, right, if you get a value that is not equal to the sum, which means something is wrong with you. But this is only to check whether you write the numbers correctly lah. Whether the scheduling policies you follow correctly or not, that one, no one can save you. Okay, you can just practice and know, like, check on your own. All right, but if you want to check whether your Gantt chart value is specified correctly here, okay, what you have to do is you can sum all the CPU cycle, and then you check is it the right one. I don't want to see got people start with 1 谁给我 start with 1我跟他讲他请全班人吃海底捞。Okay, so this is for shortest job next, non-preemptive, cannot have interrupt one. All right, now for this one, So for this one, you just draw 2 lines, okay, and then you go and calculate your average turnaround and your average waiting time. Okay, average waiting time. Okay, just calculate based on this one. Okay, so this one I don't go through. Now, shortest job next, first come, first serve done. Let's proceed with the next one, which is shortest remaining time first. Okay, this one is a preemptive. Look at here, preemptive. Now, you will allow interrupts. Okay, it can happen more than one time, of course. Now, look at this. How we going to start? Okay, I'll start with drawing the Gantt chart. Let me just change another color. Okay, the purple one. Now, you start at 0 for sure, right? And at 0, you only have process A, right? So you continue to execute. Same, this 1, 2, 3, you don't have to follow me to draw in your exam, but I just draw for you to understand. Now, execute for 1 millisecond, for 2 milliseconds, for 3 milliseconds. B comes in, right? At 3 milliseconds, B is here. And B have a CPU cycle of 2. Okay. Now imagine at 3 milliseconds, you already execute process A for 3 milliseconds. Initially, they have a 6 millisecond of CPU cycle, right? So if I already execute for 3, I have to minus 3, which means at the moment or at the point of 3 milliseconds here, your process A left 3 milliseconds. to be processed. Meanwhile, the new task that coming in, or new process that coming in, which is B, only have a CPU cycle of 2 milliseconds. Now, 3 and 2, if you don't know how to compare, you're going to hit yourself onto the wall, okay? So 3 and 2, definitely B is the shortest remaining time, right? And this is a preemptive where you can allow interrupts. So your CPU at this moment, it's going to cut it off. It says that, okay, process A, let me store your execution detail into the process control block. Okay, I'm going to run a process B right now. So don't forget, this is not done yet. Later you better bring it back, else I don't know how to help you already. Okay, so you're going to switch to process B. Okay, and execute for 1 millisecond, 2 millisecond, which means at the fifth milliseconds, right, your process B is already done. So you draw one line here. Now no more B already. Okay, now at 5th millisecond, is the process C ready? 这个6秒才来. This one come at 6, right? This is just 5th millisecond. So your process C is not here, right? So at this time, you only have process A left. You continue with your process A. Okay, boleh follow, I mean, you don't boleh follow, I also don't know how lah, because this is a recorded session, right? Okay, so now A, process for 1 second, which is 6 milliseconds. Ta-da, your process C is here. Okay, your process C is here. Now C, the CPU cycle is 4 milliseconds. Now, how many, not how many, but what is the value for CPU cycle for process A? You have to bear in mind, just now you execute for 3 milliseconds, you left 3. At 6 milliseconds, you execute for another 1 millisecond, right? You have to deduct, okay? So you deduct already, you left 2 milliseconds, right? So you compare 2 milliseconds for process A, 4 milliseconds for process C. So who is the shortest one? Definitely process A. So C, even though they come at 6 milliseconds, our CPU is going to process for process A. So continue 8, continue 7 and 8, okay? So 3 milliseconds, finish execution. We are done with the process A. So process A is also done. So now you left process C, okay, at 8 milliseconds, look right here, at 8 milliseconds, you left the process C, which have the CPU cycle of 4. So there's no new job or new task coming in, right? So our CPU is going to process with C. Okay, because the D comes at 9 seconds, 9 milliseconds, okay? And then at this moment, 8, the only process in the queue is just C. So your CPU cannot say, let me rest for 1 millisecond, then I continue. There's no such thing. So you see, there's only one process in the queue. We are just going to allow the CPU to process it. So imagine this, at 8 milliseconds, our CPU done processing A, so we'll continue to process on C lah. So C is up. Okay, C is up. Now you just continue to execute for 1 millisecond, and you see, tada, at 9 milliseconds, your D is here, and the CPU cycle for D is just 2 milliseconds. Now I cancel off this one, because C is here, execute for 1 millisecond already, right? Initially of 4 milliseconds, you execute for 1 millisecond already, you left 3 milliseconds. Now you compare 3 milliseconds and 2 milliseconds. Who have a shorter one? Donkey. Okay, so your CPU have to switch. Okay, so C, you hold on. Let me process with D first because he got a shortest remaining time. So we are going to prioritize it. Okay, so right here, don't forget that your process C actually left 3 milliseconds, but we're going to proceed with a D that only have 2 milliseconds of CPU cycle. So you got a 10 and 11 milliseconds. Now your process donkey is done. Can follow, Okay. Now your donkey is done. C is not done, C still got 3 milliseconds, So at the moment or at the point of 11 milliseconds over here, E is not here, right? So your CPU is going to continue with C as well. This one, I cut it off. Okay. The CPU is going to proceed with C. Okay. And C, we left 3 milliseconds, right? So I continue. 12 milliseconds. Okay. At 12 milliseconds, E is here. And E have a CPU cycle of 4. Now, imagine your C already execute for 1 millisecond and 2 milliseconds. So just now 1 millisecond and execute for another 1 millisecond. So I left 2. Now you compare 2 and 4. 2 have a shortest, right? So your CPU continue with another 2 milliseconds over here to complete the process C. And finally, we only have one single process in the queue, which is E, okay, and takes up for CPU cycle. So I'm going to proceed the E last and up until 18. So this is going to be the shortest remaining time first because it is a preemptive algorithm. You allow interrupts. Okay. So you're going to draw a line. Okay. Now, there's one thing I have to talk about. Okay. Let me erase something first. So in your exam, you don't have to give all these things one. This one, I just draw it up so that I can explain better to all of you, Good job. Let me rub it off. Okay, so 6 and 7, no need, no need. 8, 9 need, 10, no need. Let's rub it off. 12, no need, 13, no need. Okay, something like this. Good job. Okay. Now you draw two lines over here. Okay. Then for the calculation part, okay, let me emphasize on this thing. To calculate the average turnaround, okay. So don't confuse, okay. Don't tell me that you didn't sleep enough, okay, because you are going to take the finish time. Where's my okay? Finish time minus your arrival time, right? Okay, you don't say teacher, I didn't sleep enough lah. This A3 I take 3 law. Hello, they end at 8 . Okay, so for the task that actually we interrupt it and then come back to resume to process it, right? Make sure you get the final T finish T. So if imagine A comes out 3 times, 1, 2, and then let's say last it ended at here over there's an A, right? And then it's a 19 millisecond. You don't go and take 3, you don't go and take 8, you better take the last one. Okay, now I just going to do one example for this one for preemptive algorithm, because preemptive algorithm that is an interrupt, so I worry you guys might confused about which value to take to calculate the average turnaround time. All right, so okay, over here average turnaround time. Okay, so no matter what, I'm just gonna stick back to the process. So I start with process A. It end at 8 millisecond. Okay, then the arrival, let me scroll back. The arrival is 0. Scroll a little bit smaller. Okay, so arrival time is 0, so I 8 minus 0 to get the turnaround. Okay, the next one, process B, it ends at 5. Okay, 5 millisecond, and arrive at 3. So, sorry, this one is plus. Okay, the next one, process C, C 14, arrive at 6. Okay, the next one is donkey end at 11, arrive at 9. And followed by the E ends at 18, arrive at 12. Okay, sum them up and then divide how many process? 5 process over here. So divide by 5, you got a value. Okay, so you go and calculate your own value here. Now for the average waiting time, same as well. As long as your finish time, you get the right one, right? I don't think you guys will have any issue with the arrival time or the CPU cycle. Okay, now you see 8 at 8 milliseconds. So 8 milliseconds minus by arrival time of 0 and minus the CPU cycle of 6. Okay, followed by B and at 5 milliseconds, arrive at 3, CPU cycle of 2, and followed by C and at 14, arrive at 6 and having a CPU cycle of 4, followed by the D and at 11. Okay, CPU cycle 2, arrival time of 9. All right, the last one, which is E, ends at 18 millisecond, arrive at 12, and having a CPU cycle of 4. That's it. So this one you have to divide by 5, okay, because there is 5 process over here, and you get the average value. So you sum it up and then you calculate over here. So that's it for the shortest remaining time first. Now I actually go through three algorithm already. I try to pause the recording here and then I will resume another one. Okay.